we're going to find the measure of the reference angle for the given angle. Our given angle here is 135 degrees. They're using that Greek symbol theta to represent that angle. What we need to do is determine the reference angle for a 135 degree angle. Reference angles. We need to talk about what those are and how we can calculate them. A reference angle, that is the angle between the terminal side of an angle and the x-axis. Your terminal angle, which many books use the same Greek letter for as the given, but with a little apostrophe there, they usually call that prime. So that is the symbol that many books use for the reference angle. The reference angle is going to be acute. It's going to be between 0 and 90 degrees. So I just need to take a look at what a 135 degree angle looks like in standard position, and then look at where the terminal side is and find the measure of the angle between it and the x-axis. So if I were going to draw in a 135 degree angle in standard position, we'd have our initial side on our positive x-axis. I would take a look at my angle. It's positive, so I'm going to be rotating in a counterclockwise direction, and I would want to rotate around 135 degrees. Oops. That's our angle theta. That's the original. And then from there, what we need to do is determine what the reference angle is. The reference angle is between the terminal side and the x-axis. So this angle right here, this is our reference angle. I need to know how big this angle is right here. How big is that angle? In order to do that, we're just going to do some simple subtraction. Our original angle theta here was around at 135 degrees. And our x-axis that we're looking at here, that would be halfway around, so that's at 180 degrees. And in order for us to find that reference angle, I simply need to take those two values and do some simple subtraction there. So our reference angle for this problem is going to be 180 degrees minus 135 degrees, which would be a 45 degree angle. Again, it doesn't say in the directions you need to go through and do a drawing, but it does definitely help with these reference angles if you do the drawing. So I would at least encourage that to start with. 105 degrees. All right. So I want to either visualize, or draw out what a negative 105 degree angle would look like. In standard position, we start with our spinner on the positive x-axis. It is a negative angle this time, so we're going to be going around clockwise 105 degrees. So a negative 105 degrees would be approximately here. That would be a reasonable sketch for our original angle theta. What we are interested in doing is finding our reference angle, which is the angle left over here. If you were to go to the nearest x-axis. So here is our reference angle. If I were to rotate all the way around to this angle, that would be a negative 180 degrees, and I can just subtract those and do that calculation. When you do that, you can use the negatives that are there, or you can just subtract them and do the absolute value. That's fine too. I'm going to just do the subtraction. I do want a positive angle for my final answer. So for our reference angle on this one, I'm going to do a negative 105 degrees, and then I'm going to subtract a negative 180 degrees, which would be like adding 180 degrees. If I did that, that would give me a positive 75 degrees. So the reference angle of a negative 105 degree angle is 75 degrees. For this one, we'll take a look at a 325 degree angle. 325, if you were to sketch that into standard position, it would be in a positive direction. So I'm going to rotate around counterclockwise. And we're rotating around 325 degrees. So 325 degrees, there's our angle there, there's our terminal side. Our reference angle is the measure of the angle between that ending position and the x-axis. The x-axis here, I could say it's 0 degrees, 360 degrees, 720 degrees. We want to do the one that's closest to 325, so that is 360 degrees. So if I go around to here, that's 325. The angle that's remaining would get us all the way around to 360. So here are the two angles I need to subtract. So our reference angle on this one can be calculated by doing our x-axis number minus our angle, and that is a 35 degree angle. So the reference angle this time is 35 degrees. If you subtract these two angles and you get a negative, you can just remove the negative to get the absolute value, and that'll give you an acute angle between 0 and 90 degrees. A 70 degree angle, well, in standard position, that would look like this. $70 degrees would be there, and we're trying to determine our reference angle, and the reference angle is the angle between this terminal side and the closest x-axis, which is this one. So our reference angle this time happens to actually be the actual angle, which is weird. But that does happen anytime that you have an angle that is in the first quadrant. The angle itself is going to be the reference angle. If you wanted to do the subtraction, you still can. It's 70 degrees and then minus this angle, which would be at 0 degrees. So 70 minus 0 does give us our reference angle of 70 degrees.